All right, so often gases are mixtures, right? They're not pure. Air, for example, is a mixture of gas that is mostly nitrogen. Of course, we've got oxygen, that's what we breathe in, and there's other stuff in the air as well. What we do with this stuff is we assume that they're all ideal gases. And so if we assume that they're all ideal gases, they all basically behave the same. All we care about really is the total number of moles because we're assuming that they're all ideal, so they're all behaving essentially the same. So the total pressure is the sum of the partial pressures. And partial pressures just means it's the pressure of the gas if it were by itself. So the equation that you come up with is that the total pressure is simply equal to the sum of its parts, right? So the pressure of A plus the pressure of B plus the pressure of C, so on and so forth. The other way you could write that is the total pressure is equal to the sum of the individual pressures, right? Again, this little symbol right here means sum of. So there's different questions that could be asked about this. One example could be relatively simple, like a container has oxygen and nitrogen gas. If the partial pressure of O2 is 0.12 atmospheres and the total pressure is 0.80 atmospheres, what is the partial pressure of N2? And again, this is just a relatively simple plug and chug problem, right? So our total pressure is going to be the sum of its parts. In this case, the partial pressure of nitrogen and the partial pressure of oxygen. In this case, what we're asked for is the partial pressure of nitrogen. So we want to reorganize the equation. To do that, we'll subtract the partial pressure of oxygen from both sides. So we'll get P total minus PO2. After that, we can just plug and chug. So the total pressure here will be 0.8 atmospheres. The pressure of oxygen will be 0.12 atmospheres. And so when we plug that into our calculators, we get 0.68 atmospheres as the pressure of nitrogen.